Okay, so the general inner product also follows the Cauchy-Schwarz inequality. Okay, that means if u and v are any two vectors in an inner product space, then the absolute value of uv inner product is less or equal to the product of the norm of u and the norm of v, where the equality holds if and only if u and v are linearly dependent. Okay, so this part actually has been mentioned before. It's very similar. It basically exactly the same as the Cauchy-Schwarz inequality for Euclidean inner product. So from the above theory, if u and v are non-zero vectors, okay, then if we because we know this part, we can divide it the right part in the bottom, so we can get u v inner product divided by u norm times v norm, which is equal to which is smaller or equal to 1, right? And if we want to remove the absolute value and the u v inner product divided by u norm and the v norm should be smaller or equal to 1 and larger or equal to -1, right? So we can write down like this. Okay, and this is a unique, there is a unique angle theta in the range of 0 to pi, such that cosine theta is equal to the uv inner product divided by u norm times v norm. And this equation can be used to define the angle theta between two non-zero vectors u and v. So in fact, the angle between vectors u and v can be defined actually based on the inner product of uv. Okay? So on the other hand, so originally we would say that the vectors u and the vectors v, this is the angle between angle theta between u and v. However, if you have different definition on the inner product, the angle theta may be different, because the angle, the cosine theta, should be equal to the inner product of uv divided by u norm times v norm. OK， 所以这里是讲说，所谓的角度这件事情其实有点玄妙。本来呢，我们会觉得说角度有什么？角度不就是 u 这个向量跟 v 这个向量这中间这夹角就是所谓的角度吗？好，那但是这样子的说法，都是在我们传统，在我们意识里面的欧式内积的那样子的定义底下，我们会直接就画出这个。好，但其实这里其实是反过来，它告诉你哈，假设今天呢，我们在某一个 space V 里面，那我们定义了一个蛮奇特的 operation， 好，那它是一个 inner product。那在这样子的 inner product 的定义之下，它的角度其实是你要根据你的 inner product 怎么定义，你才会有那个角度的定义哦。好，当然了，在那样子的情况底下，我可能画不出来那个角度长什么样子。好，但是你可以从这个式子里面看到说，所谓的角度其实是就是它是它的基础是在于 u 跟 v 的内积怎么算，因为你 uv 内积怎么定义，会影响到 u 跟 v 的 norm 怎么算，然后当然就会影响到它们两者相除。那把它两者相除的东西叫做 cosine theta， 而这个 theta 你可以想象得到，这个 theta 它的定义是 depends on uv 的内积怎么定义。 好，这个观念是以前没有的。Okay, so a vector space V is said to be a non-linear space if to each vector V in the space there is associated a real number V norm, which is called the norm of V, satisfy that the first condition is the norm should be larger or equal to 0, with equality if and only if V is equal to 0 vector. And alpha V, the norm of alpha V is equal to the norm of V times the absolute value of alpha, where alpha should be any scalar. Okay, you may wonder why we need an absolute value for alpha, because alpha could be -2, right? So if you just write alpha times the norm of V, this value would be smaller than 0, which doesn't make any sense, right? So the -2 here means we point to an opposite direction, right? So the norm here means the length, so there should be no negative length. So here we need the absolute value. And the norm of V plus W is smaller or equal to the norm of V plus the norm of W, which is the so-called triangle inequality, right? Because if this is V, this is W, the length of V plus W is smaller than the sum of the length of V and the W. This is triangle inequality. Okay. So if V is an inner product space, then the norm of V can be defined like this. We have mentioned this before, right? This could define a norm on V. And here we can go through this proof quickly, because we want to show that this kinds of definition satisfy the 3 conditions mentioned here. And it said that condition 1 and 2 are easy to be verified. So here we just show the condition 3. If we want to calculate the norm of U plus V, okay, the square of the norm of U plus V, which is equal to the inner product between U plus V, U plus V, right? It can be rewritten like this. So here, by using the Cauchy-Schwarz inequality, this value is smaller or equal to 2 times U norm times V norm, right? Okay. And this value is equal to U norm plus V norm and the take square, right? So if we take the square root on both sides, then we can get the norm of U plus V is smaller or equal to the sum of U norm and the V norm. Okay. So we say this definition satisfy these 3 conditions. Okay. Okay. So now, not only the inner product can have more general definition, the definition of norm can be more general. Okay, so here in this slides, this is the most common way to define a norm. The most common way to define a norm is the square root of the inner product, right? Okay, in fact, we have another way to find a norm of a vector. Only if they satisfy these three conditions. So now we introduce a few other ways to define the norm. Okay. For example, we can define the so-called one norm. Okay. So if a vector x is equal to s1, s2 to sn, which is an n-dimensional vector, the so-called one norm is defined is written like this. Okay, we have a subscript with 1. Okay, it is defined as the absolute value of s1 plus the absolute value of s2 and so on. This is called the one norm. Okay, and the way we are most familiar with is actually the so-called two norm. Okay, two norm is equal to s1 square plus s2 square and so on. Okay, so if we use the Euclidean inner product, this is equal to the Euclidean inner product, and then we take the square root, so which is equal to the inner product between x and x. This is the so-called the two norm. In fact, for any p norm, is defined by the absolute value of x1 and take the raised to the power of p, and then we add them together and then take the root. Okay, which is looking like this. We can also define a very special norm that is called infinite norm or uniform norm or infinity norm, which is defined as maxima between the absolute value of s1, s2 to sn. So in fact, we have many ways to define a norm. So in mathematics, not only in linear algebra, but also in many other mathematics topics, if we don't mention specially, when we say norm, basically it means the two norms. Okay, if we just mention inner product, we don't especially emphasize what kinds of inner product. We means Euclidean inner product. Okay, so if the value p is not equal to 2, so for any p norm, actually it does not correspond to any inner product. Thus, the Pythagorean law will not hold. Okay, so for example, if there are two vectors s1 and s2, they are orthogonal. Okay, however, if we calculate s1 plus s2, which is equal to -3 and 4, if we take the infinity norm, which is the sum of the infinity norm would be 20. However, if we take the infinity norm of s1 plus s2, it is equal to 16. These two values is not equal. These two values are not equal. Okay, so it does not follow the Pythagorean law. However, for two norm, here we get the sum of the square of two norm of these two vectors are 25. And if we add them together first and then take the two norm, it's also equal to 25. So only for the Euclidean two norm, the Pythagorean law holds. Okay, so this is very special. Okay, so let's see some example. If a vector x is looking like 4, -5, 3, then the one norm is equal to 12. Two norm is equal to 5 times square 2. So this is the most common way, most familiar way we calculate a norm of a vector. Infinity norm is equal to phi. Okay? So a norm provides a way of measuring the distance between two vectors. So why we care about norm? Because norm defines the distance between two vectors. So if x and y are vectors in a norm linear space, the distance between x and y is defined by y minus x, the norm of y minus x, where the norm, if we don't mention spatially, it means two norm. However, we can also calculate one norm, two norm, p norm, infinity norm, and so on. So in research, actually, we usually use different kinds of norm to define the definitions of to define the distance between two vectors. Okay, so if you are interested in this, you can study more in the future, like image classification or many topics are related to measuring the distance between two vectors. Okay, so let me repeat this part in Chinese again. 好，这边有一点神奇。好，这里在讲什么呢？他说啊，这个我们刚刚前面讲说，这个内积呢，其实你可以定义出你喜欢的内积。好，那你只要符合那3个条件就可以了。好，那 norm 呢 ？norm 其实你也可以去定义你喜欢的 norm， 或者说适合你的应用的 norm， 只要它符合这3个条件就可以，它就是一个合法的 norm。好，那所以说呢，这个在学术上哈，其实我们蛮常用各式各样不同的 norm， 比如说 one norm， 其实就是把里面的每一个数值取绝对值加起来，这叫 one norm。好，那你说这个是哪个神经病定出来的呢？我也不知道，你可以去查。好，但总而言之呢，其实这是可以证明说 one norm 它其实符合这3个条件。每一个 norm one norm two norm 2.5 norm， 如果你高兴的话 3.8 norm 都可以。好，你只要能够证明你定义的那个 operation 符合那个3条件，它就是一个合法的 norm。好，那一般来讲，我们在绝大部分的情况底下不特别讲，我们讲的其实都是 two norm。好，那 two norm 的话，就是 S1 就是每一个人的绝对值取平方，每一个人绝对值取平方加起来，然后再开根号嘛。好，那这个的话呢，其实从这里等号写到这边，这中间你可能就有一点疑虑啦。好，这个其实有一个假设，就是说我们现在的 inner product 是 Euclidean inner product， 因为我们刚刚前面有讲嘛，内积不见得一定最后是长这个样子。对不对？你高兴做一个很特别的内积，它算起来就可能不是长这样。好，那我们现在是假设说，我们都不特别讲的情况底下，其实这个其实就是一个欧式内积，那它也可以写成是这个形式。好，那任何的 p norm， 其实 p 带任何的值，它其实就是这个形式啊，其实就是这个形式。好，那 infinity norm 其实就是取绝对值，然后取其最大者。好，那这些奇奇怪怪的东西呢，在研究上有它的用途。好，我们常常在做各种不同的研究的时候，我们常常会把资料表达成向量。那我们常常要去比对这个向量跟那个向量像不像。好，那这2个向量像不像？我可以用 one norm， 也可以用 two norm， 也可以用 p norm， 也可以用 infinity norm。好，那通常学这个文献上有可能会叫它 L1 distance、L2 distance、LP distance、L 无限大 distance， 其实指的就都是这些意思。好，就是说你今天 如果是这样，那就是 LP distance， 那这个是 L 无限大 distance。好，那你说为什么要 P 要带入各种不同的值？那要带哪一个值效果会最好呢？答案是不知道或不一定。好，那就要看你的应用而定啦。好，那有的研究啊，可能会去证明说，哦，在什么情况底下，我用 L1 distance 最好，我用 one norm 最好，什么时候用 two norm 最好？好，那如果呢，有些同学，如果你现在是走的比较快的，你已经开始有在做一些 deep learning 的研究。deep learning， 你有使用 deep learning 不要讲 deep learning， 你有在使用 deep learning 的话，那么你在训练你的类神经网络的时候，你就要去定义 loss function。你所谓的 loss function 就是指你预估出来的，通常是指你预估出来的向量跟你真正标准答案的那个向量中间差多少。那差多少就是这个啊，就是 exactly 就是这个，就是在计算两个向量之间的 distance。那你这个 distance 你高兴用哪一个？你可以试试看 one norm， 你可以试试看 two norm， 你可以试试看 p norm， 你可以试试看无限大的 norm。好，当然除了这些之外还有别的啦，你可以用什么 cross entropy， 你可以用什么什么什么这样子。OK， 好，所以这边的话呢，就是用比较广泛的这个意义来跟大家讲这个 norm 的这个定义。好，以上是 Session 5.4